So to everyone who's just joined and kind of filtering through in the last couple of moments, hopefully you're in the right place. This is the third webinar in a series that we're running on evaluating causal impact. So today we're going to be focused on randomized control trials. I'm sure many of you joined previous webinars. A couple of weeks ago, we had a webinar on quasi-experimental designs, and we have got 2 following webinars. So we're running 5 as part of this series in total. While people are still trickling in, just a couple of housekeeping points. I'm sure you're all quite used to this by now, but we're using the webinar formats in Zoom. So what that means is that you're automatically muted and also your camera will be off. So you won't be able to see and hear each other. Don't worry, that's the plan. That's how the webinar format works, but you should be able to see and hear us. So I'm Rain Sherlock. I'm the head of evaluation at TASO, and with colleagues Sonia and Lauren from Cambridge University and the Brilliant Club, who are going to be talking us through today's content. You should also see at the bottom of your screen a little Q&A box or a little Q&A icon. So this is where you can ask questions throughout the webinar, and we will leave some time towards the end of the webinar to answer those questions. So don't feel like you have to wait until the end. If you do have questions as our presenters are speaking, feel free to just drop them in that little Q&A box, and we'll kind of field as many as we can, as many as we have time for towards the end of the session. I know we are quite pushed for time and it's about 2 minutes past. So while people still continue to trickle in, I think I'll hand over to you, Lauren, to get us started.
Super, thank you, Rain, and welcome everybody. Thank you for joining us on our webinar on randomized controlled trials, also known as RCTs. As Rain mentioned, this is part of a range of webinars that we are covering on causal evaluation. Today, you are joined by myself and Sonia, so we will be taking you through this webinar. If you've also joined us for previous webinars, then you may have met our other colleagues who have also been working with us on this project. Just to begin with, to give you a little bit of sort of context of the project more broadly and the purpose of this specific session. And so this is a project that was commissioned by TASO, and it was really around focusing on the enablers and challenges to conducting evaluations that generate causal evidence. As part of this, we did a consultation with the sector. We got feedback around universities in particular wanting more practical steps around the way to carry out an RCT. We also had feedback around increasing awareness of different RCT designs. And so this webinar is very much about addressing that feedback and also contributing to the wider set of resources that TASO has around causal evaluations. In terms of what we will be talking through within the session, so we will be giving a brief overview of RCTs as we're contextualizing them within causal impact. We will also be using TASO's evaluation cycle. We will be talking through the implementation of an RCT using these different steps. We do, as Ray mentioned, we do have quite a lot of content to cover. So we will be going through some of the content quite quickly, but really pausing where it's sort of really crucial that people have that context and understanding. We also will be repeating some of the slides that we've talked about in previous webinars. And so this is just sort of continuity, but you can also revisit those webinars as well. Okay, so first question, an important question, why do an RCT? And so we know that within the sector, within the university access and student success space, we need more causal evidence. And so this is what the Office for Students refers to as type 3 evidence. We know there isn't as much evidence as what we have for type 1 and type 2. And this is really around understanding or helping us to understand collectively what is having an impact and what's not having an impact. And so by generating this causal evidence, we really know what is impactful, where should we be placing our resources and efforts, and where perhaps should we not be placing our resources and efforts. Moving rapidly on, what is an RCT? Okay, so to really kind of go into the kind of crux of this, we really need to understand, what do we mean by causality? When we're thinking about causality and what we're trying to do within the work we're all doing, we have an intervention, we have an activity, and we're trying to understand what is the causal impact in relation to a particular outcome of interest. And so the outcome could be progression to university, the outcome could be critical thinking. But alongside our intervention or our activity, we have a range of other things going on. And so we have a whole bunch of other factors which will be contributing to the outcome of interest. We're not interested in all of these other factors. We really want to understand what is the impact, what is the specific impact of our intervention. And so these other factors we refer to as potential confound or confounding variables. And so what we're doing with RCT is we're isolating and we're separating the intervention from all of these confounds. And just to kind of walk through the way we are doing this in practice, what we are doing is we are generating a counterfaction. And so what would happen if the intervention did not take place? And to sort of think about this and what this means within the context of RCTs, we are creating counterfactual, and so a group of individuals who do not take part in the intervention, we are randomly allocating either at an individual level or a group level, and certainly we'll talk through that distinction in a bit more detail later on. And so we are randomly allocating, and so we have the quite simple example here of if you're tossing a coin and you're allocating your individuals to either your intervention or to your control. And then because we are doing random allocation, we are, in terms of those confounds which we're trying to avoid, they are then sort of equally or evenly distributed across the two groups. And so the only difference we're left with is the intervention. And so either they received the intervention or they did not receive the intervention. And then this allows us to then demonstrate causal impact. Okay, so thinking about kind of the beginning phase in planning your RCT, and what means you're going to do, we're going to take different sections of this. So I'm going to talk through the planning and measuring, and Sonia will talk through the reflection and a bit of the planning as well. And I'm also going to talk through the diagnosis stage, which is step number 1, which is also very important. Okay, so just moving back, getting ahead of myself here. Let me move back a slide. Okay, so step number 1, diagnosis. And so we all know that developing a really clear theory of change is a really important part of doing evaluation effectively. And TASE have a really helpful set of resources and tools and templates around creating these models. So we know that universities are creating their theory of changes. We at the Brilliant Club also use theory of changes to really understand what are the causal mechanisms, what are you doing within your intervention, within your activity, which you think is positively contributing to your outcomes of interest. And so this is where we should all be beginning, whenever we're doing an evaluation, irrespective of whether we're doing an RCT, a QED, or another type of evaluation. In terms of using your theory of change into your evaluation, I'm just going to click through all of these at once so we have everything on the screen. So importantly, when you're putting together and you're mapping out your theory of change, you are identifying what are your key outcomes. And so what outcomes are you trying to impact from the students, from the young people engaging in your activities. And within this, we make the distinction between primary and secondary outcomes. And specifically within an RCT, you will have a primary outcome. And so that's what you will be reporting on when you're reporting the results of your RCT. And so what is the main outcome which you're trying to bring about and you're trying to change? And then in addition, you might have other outcomes which you think your intervention or activity is associated with. but that's not the main thing that it's trying to do. In terms of thinking about your secondary and primary outcomes, they might be behavioural, they might be non-behavioural outcomes, and we'll come back to talking about measures a little bit later on within the session. The other thing we need to think about within kind of the practicality of your intervention or your activity is what are the causal mechanisms? What is the thing your intervention is doing? Because this is also important when you're thinking about your RCT, because it would impact things like your sample sizes. We need to know what is the specific thing your intervention is doing. And then that will feed into where you set up your evaluation and also some of the statistical and numerical decisions that you make. Okay, so step 2, planning. Me and Sonia are co-sharing this section, so I'll shortly pass over to you, Sonia. Okay, so this is sort of practical considerations and framing. And so the first thing you need to do is you need to gather your team. And this will be a range of people. So this will be people with evaluation expertise. This will be practitioners with really deep expertise of the programs and delivering programs and constructing and developing those activities. You will also need somebody with statistical expertise. And I think it's important to acknowledge that at this stage, you might not be drawing upon statistical expertise from within your own team. You might be drawing upon this expertise from your institution more broadly, or you might be drawing upon this expertise from an external. And so there are a range of options when you're thinking about bringing in that statistical expertise and what you need to do. But really the important message is here, in order to do an effective RCT, you will need a range of people coming together. So evaluators, practitioners, and also statisticians or people with statistical expertise. And then when you're sort of going through the planning, one of the most crucial things you need to do is have your research questions really clearly articulated. And your research questions will connect through to your theory of change. Your research questions need to be quite specific and they need to be focused. They need to be what we call measurable or researchable. And you need to make sure you're using a research design which can effectively answer and address your research question. And so this is an example from TISO in terms of the way you can go about thinking about the structure of your research question. And again, being as specific and precise as possible is really crucial here. Okay, so now we're going to go into some more detail, selecting your RCT design. And there are a number of different types of RCTs. We are going to talk through some of these, and then we're also going to talk through the measurement as well. But for now, I'll pass over to Sonia, who will talk us through some of the different RCT options.
Thanks so much, Lauren. So welcome, everyone. As Lauren has already mentioned, we're still within the planning stage of an RCT, and the absolutely essential element of planning an RCT is to plan really early. And once you've understood what the intervention is that you're trying to evaluate and have undertaken your theory of change development to understand the causal mechanisms, it's essential that you think about the types of RCT designs that you might want to deploy. And so today we'll go through a couple of them. Not all of them. There's many out there and many variations on the RCT design. All at their core rely on the logic of randomization to create this counterfactual. But in the simplest terms, the simplest version of RCT is one where participants are randomly assigned to one intervention and one control group. Now, that means that by the logic of randomization, we hope that we will have balanced all these other potentially confounding factors that might affect the outcome. So when we compare the outcomes of the intervention and the control group respectively, that difference that we observe is the causal impact of of the intervention. Now, it's really important to note that within RCTs overall, we're not saying that things don't change over time. We're not saying that things don't happen. The higher education sector and everything that happens within it can be quite messy as an intervention space. But what we're saying is that by the logic of randomization, we're saying that these changes occur in a balanced and uniform way across the intervention and control group, and that's what allows you to pull out this causal impact of the intervention. Now, this is the simplest form of an RCT. If you're interested in slightly more complex RCT designs, a factorial RCT might be the next step or the next option that you investigate when you're planning your design. And in a factorial RCT, participants are randomly assigned to one control group and to several intervention groups. Now, usually factorial designs are really useful when you're trying to understand either competing or complementing interventions, or when you're trying to understand the content, something that you're delivering, and the modality of that delivery. So it's quite common when, for instance, you're trying to provide information, you're testing the impact of that information provision, but you're also trying to understand at the same time whether the way in which the information is provided in and of itself generates different or differential impact. So a standard example would be when you're testing information provision, for instance, around the university application process, and you're testing whether providing that by text message, email, or some other combination of these two options is better than not providing anything, which is your control group. And actually, we'll come back to that because there are ways of tackling that, not providing anything to the control group. Now, beyond a factorial design, we also have a different type of RCT design, and it's what we call a cluster RCT. Education, in particular, as a whole discipline, sees quite a lot of these cluster RCTs take place because they are the kinds that allow for the clustering of individuals in wider units or in wider settings. So our usual type of intervention where we have students or learners clustered in schools or colleges or universities, and we work across a number of these institutions, is a cluster RCT really comes into its own. And actually, what you then randomize, instead of randomizing individuals to either a control or an intervention group, or indeed many intervention groups, you randomize these higher level units, these institutions, the schools, the colleges, the universities. We still undertake the analysis at the level of the individual, but the logic of randomization and the randomization itself occurs at the level of the school or similar. Now, this type of RCT design addresses an issue of contamination and spillover, and that's something that we will go through in a bit more detail. It comes therefore with advantages, but it also comes with the disadvantage of requiring far more individuals in your design, particularly thinking about the fact that when you're randomizing schools or institutions, it's that number of schools or institutions that represents your overall sample size for your RCT. So clearly implications there for sample size and how large a study could be. Yet they happen, these types of RCTs, quite commonly in education because they reflect the nature of our sector. Now, as we were saying, there are a couple of common challenges and that we face when we do randomized control trials. The first one is contamination. And that's when we're concerned that the control group inadvertently, sometimes deliberately, but usually inadvertently, engages with the intervention at a time when they are not meant to do that. So again, I was saying that there are ways of tackling this logic of potentially not providing anything to a control group. And the way to do that is by a mechanism that we call a waitlist design, whereby the control group does not receive the intervention initially, but does at a later point in time after your outcome measure collection, something that Lauren's going to come back to in a couple of minutes. We're also potentially concerned with spillover effects, just like we said earlier that a cluster RCT is very good at tackling. Now, spillover effects happen when we're concerned that the control group may be indirectly affected by what's happening in the intervention group. That's usually when what's being delivered or the kinds of intervention program activity that the intervention participants have access to somehow makes its way into what control group participants do. Or indeed that there's other factors, other structures, other processes that are influenced by the intervention itself that then influence the control group. And so we're trying to find a situation where we have very little spillover effect to keep our design as clean as possible, if you'd like. We're also thinking in terms of these standard challenges around attrition. And that is particularly when we're thinking about dropout and people or institutions refusing to engage either initially or halfway through or towards the end of the trial. And we are particularly thinking here about differential attrition, specifically the quite common phenomenon that dropout seems to be higher in control groups than in intervention groups. So the individuals that are randomly assigned to not receive an intervention or receive it later have a slightly lower chance of sticking with it to the end. And you can start to see why from a just personal psychological incentive structure that might be. And what we need to do when we're planning, remember we're in the planning phase here, what we're trying to do is think about or predict how high that level of attrition might be, and then work it into our sample size and make this as contained as possible. Finally, we think about ethical conduct of RCTs all the time. And the common question is that of how could we possibly do a kind of evaluation where we're withdrawing or not providing an intervention to a particular group, namely the control group. So the waitlist design tackles that potential ethical consideration. But beyond that, I think it's really important to realize that the very reason we are doing an RCT in the first place is because we don't have sufficient evidence to say that the intervention that we're carrying out, at least in this form, impacts the outcomes in the way that we expect it to. And so it could be that actually what we're finding are negative or undesired effects. And in that case, we have a different ethical conundrum to which we will return later. But the point is that given that we don't yet have enough evidence and we're building that through the RCT, ethically speaking, you could argue it is still reasonable to run these types of designs. And actually, for thinking about education and higher education overall, there's lots of things that people have access to in different levels and at different points. And so a waitlist design can really help with those considerations if you're thinking about them. Now, these types of challenges are also addressed by other kinds of RCT designs. And again, I said we're not going to go through in depth through all of them because there's so many, but just as a sort of brief preview, we have crossover designs, and that's where control and intervention groups swap over halfway through a trial. And it's essential that before that swap over point, some form of outcome data has been collected. And that's to be able to understand in the first part what the impact of the intervention is, and then also potentially in the second part as well. But by the end of the full trial, everyone will have had access to the intervention. We've already mentioned waitlist controls and what that can bring. And the final type of design in terms of RCTs is what we would call a stepped wedge design. And that's where we have a very large group of people to begin with in the RCT, and then we randomly assign increasingly large groups of this to take part in the intervention. Or we assign them to start the intervention at staggered time points. Essentially, they're sort of building up. You see this sort of stepped, and the wedge essentially reflects the totality of the sample that is ultimately taking part in the intervention. And by the end of the intervention, everyone will have had at least some chance of engaging with the program that you are evaluating. And so there's a way to tackle both the ethical considerations here, but also issues around nutrition and issues around spillover and contamination with these kinds of designs. Now, I mentioned earlier that one of the challenges that we have is that we really need to think about our sample size and plan accordingly ahead of time for any potential attrition or dropout. And actually, we have to be very careful here, because the sample in an RCT, as with any research, but very particularly in RCT designs, the samples need to be large enough to allow us to check and test for the kinds of effects that we expect our interventions to actually have. And so when we undertake the planning of an RCT, we usually do something that we call power calculations that tell us how many participants and how many individuals or schools or whatever we're using in our RCT design are needed to have a good chance, statistically speaking, of finding an effect of the magnitude that we expect our intervention to have. And so we're trying to balance here between the chances of finding a false positive, that's when we find an effect but actually one isn't there, and the false negative, that's when we fail to detect an effect but actually it's there. And we don't want any of those situations. And sample size calculations really early on can help to mitigate these issues. Now, the point is that statistical power can be a bit of a complex topic. It's essentially about the kind of likelihood to test and detect a particular effect of a particular magnitude. And by effect, we mean the difference between the control group and the intervention group in a simple RCT design. In other words, that causal impact that we're after in our evaluation. Now, there's lots of online power calculators out there, and they all do something called finding a minimum detectable effect size. And that's a mouthful, but that's what it is. Or indeed, if we know the minimum detectable effect size, find out what sample size we need for that. And so it'd be very good in your planning to bring in that expertise that Lauren was talking about in terms of you having assembled your team that comes from a statistical perspective and looks through the power calculations in detail and essentially tells you from a planning perspective what sample size you require to be able to run your trial. So there's a variety of these power calculators. We're not going to go through them now, but there's one in particular that is particularly helpful. I should say we're not associated with it in any way. There are others available, and you can use any kind of software that you like. I mean, you could even calculate this yourself by hand in Excel if you want the formulas. But there is a step-by-step spreadsheet essentially where you can go through a process and then input a variety of parameters. And particularly what's important here is to consider the pool and background evidence that you might already have in your intervention in terms of, or about your intervention, in terms of the likely effect it's going to have. And this is really important. If you think your intervention, your program that you're evaluating is going to make a very large difference, if you think the causal impact is going to be very, very high, then you can have a trial with a smaller sample size, because you'd still be able to detect that large effect, that large impact with a relatively small sample size. However, if on the other hand, you have an intervention or a program that you think makes a small amount of difference, this is meaningful, but statistically speaking, it's small or tiny, however you want to think about it, then you will need proportionally higher numbers of participants in your RCT, because you want to get that precision in your analysis, and that only alongside other parameters, comes through a large enough sample size. So it's just really important to think about this. And as you're thinking through this process of power calculations and determining your sample size, to then augment that by the rate that you thought attrition was going to happen at. So if you think you're going to lose 50% of your sample to dropout and a lack of engagement from students, let's say, then double up initially to make sure that you have enough sample left in your trial by the end. Once you've done all of this, once you've thought through all of this and planned, I apologize for the noise behind me if you can hear any, it's all good. The key thing is to create a research protocol. And again, really important to plan your RCT early, because that is the way that kind of lays out the coherent structure of your evaluation design. And the best way to do that is to use one of the existing templates to help you plan and to help you report what that plan actually is. TASO has a number of templates which are available online. Also, if you can, we do encourage you to pre-register or pre-publish your trial design, and in particular to pre-publish the protocol. And a protocol is essentially everything that you're planning to do, but within that, the publication ensures that you have something that you hold yourself to account, and something that says, this is what we're going to do, this is the overall design, this is the analysis we're going to undertake, this is how we're going to interpret our results. And then when you actually get to the stage of doing it, you should stick as closely as possible to that protocol, making everything very transparent, replicable, and essentially following good practice across all of this. Now, once you've designed your study overall, once you've designed your evaluation, perhaps you have a pre-registered protocol, although these two steps might come together at the same time. Really important to think about ethical approval or endorsement or ethical review. And as part of that, engage with your institution early, consider all relevant aspects from consent, permissions to use data that already exists, which could absolutely be the case in RCTs. Think about data protection issues as well, which sit alongside ethics. And if in doubt, start early and look into the TASO guidance around research ethics, because it's really important to kick off this process with plenty of time. And of course, you can only engage in it once you know what your trial design is likely to be. Now, assuming this goes smoothly and you have secured ethical approval from your institution, the key thing then is that you can essentially start to get going. And so you start recruiting your participants, again, planning well in advance and really early. I think this is a key theme emerging in terms of RCT planning. And keep an eye on what's happening in terms of participant uptake. Assuming you've reached your overall level of recruitment that your plan, your power calculations had told you need to reach, then the sort of critical point comes where you split, you randomly allocate your overall pool of participants to the respective control and intervention group or groups, depending on your trial design. Now, it's always really good practice to pre-specify how this might happen in your protocol. Say, this is how we're going to randomize, and then randomize in precisely that way. If possible, consider having someone else run that randomization for you so that you are not directly engaged in that process. Again, you're trying to keep the trial as clean as possible. Consider also that there is a variety of things that you can do when you randomize, again, with a view to minimizing the potential impact of confounding factors. So going back to that first slide we said about, why we want and how we want to run an RCT, and of defining a counterfactual. That's what we're trying to do here. Define a counterfactual in a way that minimizes the potential confounding impact of other factors. So if we're thinking that specific other factors matter for that outcome, we can do something called stratification, where we could take that characteristic, split our initial sample by that characteristic, and then randomize within these groups so that we have equal, uniform, balanced distributions in each of the groups defined by this characteristic. Gender is a classic example. Region is another classic example. If you're working with institutions in different parts of the country, you might want to say, actually, what we want is to make sure that we have the same number of participants in control and intervention groups across the different regions that are taking part in the trial. We can also consider things like blocking, where you define a group as a block, and then you randomize individuals into that block, or schools, if that's what you're working with, or universities. But the logic being that you create these blocks, and that by design and by definition gives you balanced sample sizes. In other words, similar numbers of observations of individuals, whatever, in your control group and in your intervention group or groups. And again, remember that point about independence. If someone else can run it for you, that would be ideal. And I'll hand over back to Lauren.
Super, thanks, Sonia. So we now will look at measures and thinking about the types of measures we can use when we're focusing on our outcomes. This is a helpful reminder. Only now can you start delivering your intervention to the appropriate group. So in terms of measures, whenever we're thinking about the way we can measure something, importantly, we want it to be reliable, and so we want it to consistently measure the outcome. We also want it to be valid, so we actually want it to be measuring the outcome, which sounds quite straightforward, but if you think about the range of outcomes we're measuring within university access and student success in general, they're quite complex outcomes, and so we want to make sure we are definitely measuring those outcomes in a valid way. We also, where possible, we also want the measures to be objective. And so we put together this range of weakest to strongest in terms of the quality of measures. And we would recommend that when you're choosing measures, you want to be aiming for at least a level 3. And so just to go through 1 to 3. So number 1 is rank or impact. And so that for many of us will be enrolment into university, into higher education. Number 2 is around what we often refer to as interim or proxy outcomes. As the example we've given here is the reported applications to higher education. Number 3, which we know is quite a big focus within the sector, is around validated scales. And again, we've given it one example of an outcome, which is to do with sense of belonging. And so with validated scales, we know they are reliable and they are valid and they are fit for purpose. And so these are the types of measures you should be focusing on ideally when you're thinking about measuring outcomes to do with university access and student success interventions. In terms of the measures that are available, so we are, and I think I speak for Sonia as well, we're really pleased that within the sector, we're starting to see emerging a range of validated measures and scales. This is exactly what we want to be happening, because we want people to have the choice to decide what is the most appropriate measure for your context. And so myself and Sonia and colleagues from the Brilliant Club in the University of Cambridge worked with TASO to develop the Access and Success questionnaire, the ASK. And we've listed the intermediate outcomes we measure within that questionnaire. We also want to highlight that there are other measures, sources of measures that are validated that also exist within the sector. And really the message is to encourage you to use the measures and the scales which are most appropriate and most suitable for your context. Because making sure you have a measure which fits your purpose is absolutely crucial when you're developing and designing an RCT or any evaluation. Okay, so and then just we're going through some of the steps when we're thinking about measuring. And so in terms of collecting and storing data, an obvious thing but I think important to say is make sure you know, in terms of recording your data, make sure you know which individuals were in the intervention group and which were in the control. especially if you're doing the intervention over a long period of time and your evaluation is running for some time, just make sure you're documenting everything really, really clearly. Also, if possible, if you can collect your baseline data before you do your randomization, you are then able to do that stratification, which Sonia mentioned. And so this is around taking observable characteristics. And so it could be gender, for example, making sure that they are equally represented between your intervention and your control. The other thing to make sure you do is, and again, hopefully quite intuitive, but I think important to say, is around make sure you collect your outcome data. And we often know that when you're doing evaluations, sort of getting the baseline data is often much simpler than getting the outcome data at the very end. And so making sure your data sets are as complete as possible. In terms of analysing your data, so just a couple of points here. And so if appropriate and if relevant, doing some balance checks. And so this, after you've done your randomization, and you can just do this descriptively by looking at the numbers between your intervention and your control, that you're checking for whether your characteristics are balanced between your two groups, if you have an intervention and a control. And so to use the example of gender again, whether the number of males and females in each of your groups are similar. And so you can do that based on descriptive statistics alone. And also, as Sonia's mentioned, we also need to consider attrition. We know attrition is especially a risk within educational trials. And so tracking that through and also putting in place mitigations. And so, for example, do you need to oversample to account for the fact that you might be getting some dropouts? And finally, on the sort of measure step, once you have all of your outcome data, you can then do the exciting bit and begin your analysis. You should be following the pre-specified analytical approach that you set out at the beginning, and that hopefully you have in that pre-registered protocol document. And so this is really important from an objective point of view, but also to make sure that the RCT was carried out in the most robust way possible. And again, just encouraging people to think really early on in that planning phase around getting additional support if needed. And that doesn't mean that you need somebody to support you throughout the entire RCT, but bringing in expertise kind of where relevant as you go through those 4 different stages and steps. And on that note, because I'm very conscious of time, I will pass back to Sonia.
Thank you, Lauren. So the key thing is that once you've undertaken your analysis, you have your results of your trial, but you want to make sure that they operate within the constraints and within the parameters that you initially set for your trial. So the first thing to do is to recheck your statistical power and your minimum detectable effect size at the point of the analysis. And that's a really important thing. And if you look and if you read RCT reports, you will see that most people usually do it at 3 points in time. Protocol stage, at randomization, and at analysis stage. And that tells you how attrition or dropout actually happens and how it affects the overall trial. Now, assuming that you've checked your power calculation, you end up with pretty much 2 solutions or 2 results there. Either that you have a sufficiently large RCT, in other words, that you've maintained and retained the power that you initially planned, or that you don't. And so we're going to go through the first part first and then get through the latter, essentially what happens if you don't have enough of a large sample by the end. So assuming that you have a sufficiently large RCT, there are a variety of options in relation to the kind of statistical result you obtain. And this could be statistically significant and positive, which you deem to mean that the intervention has a positive impact on the outcome. In other words, the results of the outcomes of the intervention group are higher than those of the control group. You could also look at a statistically negative effect, if that's what your analysis emerges with. And that should be taken to mean that the intervention has a negative impact on the outcome. And so there's a difference in favor of the control group this time, in terms of that outcome, primary outcome that you're exploring. You could also find a situation where you have a null effect. Specifically, that means that statistically that is a non-significant effect. So you have to conclude that the intervention has had no impact on the outcome. And actually, wider methodological literature says that this is one of the very common results for a lot of trials in education and higher education more broadly. And it's something that we should be mindful of, because the main reason that's happening is because the trials are too small, hence us emphasizing this point about attrition and making sure that your samples are large enough. Now, there's one final thing here, which is to consider that a negative effect might actually be desirable. Specifically, if you're looking at an intervention that is meant to reduce, minimize, lower a particular outcome, the incidence of a adverse effect, for instance, then you might actually be looking for a negative effect. So simply because a statistical result is positive or negative, has a plus or a minus sign, doesn't necessarily mean that the intervention has had a bad impact on your outcome. So you have to consider, going back to your theory of change, what your interpretation of that effect actually is. And once you've understood that, whether it's positive or negative, you want to determine whether this effect, the impact, the difference between your outcome and your intervention is small or large. And that's what we mean by the effect size. It's really just a simple way of capturing how big that impact is. And those of you who took part in the first webinar might remember a discussion of the combination of effect size and statistical significance. That webinar will be available online as a recording, so we do encourage you to look and listen at that, to that as well. And now the thing is, an effect size captures just the magnitude of the effect. And so it's best practice to report it in a standardized form that allows comparisons between trials. And this makes use of something called a standard deviation, or a measure of dispersion around the mean, around the average, which is what you expect sort of your outcome to be. And it's really important, alongside determining whether your effect is small or large, to also think about its practical significance and its practical magnitude as well. So yes, statistically speaking, small, large, positive, negative, but what does it actually mean in real life for your participants or other groups of people you might want to engage in this intervention? If, however, you find no positive or negative effect and instead you find a null result, you might want to explore why that is. And having eliminated a methodological explanation for this, you can go into potentially an implementation and process evaluation, which often sits alongside an RCT, to really understand what has happened there genuinely in terms of the intervention that results in those kinds of outcomes. And actually, it might also be possible that you find a null or negative effect of the type that we discussed for a variety of reasons. It might be about the implementation and how that has gone. It could be that the theory that essentially drove the intervention in the first place isn't working as you planned it to work. Or it could be that what you're capturing with your outcome isn't the specific outcome that the intervention is actually making an impact on. And again, it's really good practice to be able to link back to your theory of change and understand why that might be. There's a variety of other things that you want to consider. Specifically, if you've identified a statistically significant negative result, and you've ensured that this isn't something that is actually desirable, and you want to think through the ethical implications of this, because these are really important to consider what you want to do next. Do you want to stop the intervention? Do you want to carry on but tweak it? Do you want to change it? And I think those things are important considerations to take into account towards the end. And finally, no matter what you find, and I do know that this causes some trepidation amongst the wider evaluation community, but this is really important. Publishing results, reporting results, whether statistically significant, whether statistically non-significant, or indeed whether your trial is simply large enough and the only conclusion that you can make is that you cannot detect an effect of any kind because your trial is not large enough, it's extremely valuable to the wider sector to report these results, because there is huge learning in all of this. And so myself have reported results of non-significant and null result trials, quite a few actually. And yes, it can be quite challenging, but actually on the whole, I think it's been an extremely valuable thing to have done. And on that note, I'm mindful of time, we'll open up for questions. And I think there have been quite a few already.
Absolutely, there have. Thank you so much, both to Sonia and Lauren. So the questions are flowing in, and I'll do my best to group them, and also let's try and take it sequentially. So kind of back to the very beginning, Mauricio is asking if you could give a couple of examples of different methods for randomization and how we can use those methods in higher education specifically. Sonia, I might start with you if that's okay.
Yeah, that's absolutely fine. So normally we undertake randomization in computer software. And so there's a variety of ways of doing it. The simplest way of doing it is to use a random number generator and sort of generate random numbers for each of your participants, which you have obviously no control over, the software has control over. And then you say, depending on how the split is between your control and intervention group, let's say we have a simple RCT design, you then say, well, I want to take everyone over a certain value of this random number to be in the control group and everyone else in the intervention group. That would be one option. And of course, you have no control over what those random numbers are for the individuals, so it's all clean and it's independent of yourself. You could do something called a re-randomization as an approach, which does this process, but in the back end of the software many times, something like a bootstrapping procedure, and you do it many times until the software says, well, we've reached a sort of a point of equilibrium, of balance, and that's the sort of randomization result you go with. None of that is, again, you don't have control over what comes out of it, and that's really important. It would be even better if you were what we call blind to allocation. In other words, that we didn't know which participants in our sample end up in our control group and in our intervention group. But of course, that's very hard to do, extremely hard to do, and sometimes impossible if you're working on the evaluation from the sort of intervention program team itself. So it doesn't invalidate the study in any way, but it's good to remember that in certain cases it could be possible. There's other ways of doing it as well.
Thank you. Sticking in the plan phase for a moment, we've got a question about design. So could you give an example of a situation where a stepped wedge RCT might be appropriate?
So it really depends on the intervention. And I think that there could be many different situations where this could be the case. But for instance, if you were doing something where there would be sort of continuous provision of a certain type of activity at the same level of intensity, let's say over an academic year, and you took a very large group at the beginning and you said over time, you'd create these random groups. You say these people are in group 1, group 2, group 3, group 4, group 5, I don't know. And so group 1 starts from the beginning. Group 2 starts from, I don't know, month 2 onwards. Group 3 starts from month 3 onwards. And at each of those critical points before group starts, you collect some outcome data. And obviously that can be quite challenging in terms of outcome data collection because it's a lot of it. But if, for instance, you have, and you can use the structure and the nature of your academic year or of your school year or of your course assessment, whatever it might be that you're working with, to help with those points of data collection, then that could be mitigated. Lauren, maybe you had another example.
I completely agree, but also just to sort of add an addition, I think if you're thinking about that type of design, you have to be led by the practicalities of the implementation. And so it's more about what kind of fits your delivery purpose and context, and then kind of retrospectively fitting that design on, because as Sonia says, it is sort of quite a heavy duty design, and so you have to be confident that it's going to practically work within your program and within your intervention.
Another idea just for people interested in the design is to look at examples where they use local authorities to roll out policy level intervention. So not specific to HE, but a nice way that explains the stepped wedge design. I'm going to move us on to our next question, which is about attrition. So we have a question from Lynn asking how you would tackle attrition in a control group, specifically when you're in the planning phase. And would it be appropriate to have a larger control group than the intervention group to mitigate the risk of attrition?
So it is possible to have a larger control group. You would then be very careful about how you would handle unbalanced treatment, because all of this sort of design stuff in RCTs comes from a medical space initially, but we try to steer clear of that, but that's really what they are. So okay, intervention groups, I suppose. I think you could do that, have unbalanced groups, but then you have to be careful about it, because the implication of that is that your statistical power shifts a bit. So it's possible, but just be careful. Essentially, ask a statistician friend. Now, in terms of how do you mitigate attrition? One way of doing it is incentivizing the control group with something that you deem to not make a difference for the outcome of your trial. So if you're, I don't know, if you're testing an intervention, or if you're evaluating a program to improve knowledge about higher education options, you might be thinking about incentivizing the control group with something that isn't affecting knowledge about higher education in any shape or form. I don't know, things that are sensible and ethical within the context. What we've done in the past is somewhat sittily pizza nights and things like that, that individual students and teenagers respond well to. So it can be very practical. The other thing to think about is whether you can incentivize the schools or colleges that this all works within, so that there's a kind of an agreement or an attempt or support and a partnership to be able to collect the data. And the other point is, going back to Lauren's point earlier about practicality, is to try, if you can, either to piggyback off of existing structures or existing points of data collection, or sort of match practices that are already embedded in the particular institutions or places that you're working with, to sort of make it more straightforward for people to engage, not just in your trial, but in the outcome data collection. And if you do that, then you can kind of minimize the dropout rates. But dropout is an increasing issue in higher education evaluation. I know we're short on time, but we ourselves have done a trial, or tried to do a trial this past academic year, and it started well and it did not end well because of very high levels of attrition, circa 70%.
Wow, that is high. We've got a couple of really nice questions on power. So the first question is hopefully quite simple with a kind of short answer, and then a second question that I'll pitch to you as well. But firstly, is power analysis only relevant to RCTs, or do other experimental or quasi-experimental designs require power analyses too?
So other experimental designs require, and quasi-experimental designs require power analysis as well. The advantage of quasi-experimental designs is that, by definition, almost, usually they engage with data that already exists, or with sort of large systems that are already in place. So sample sizes themselves are not the kind of key barrier to those kinds of designs. So you might be wanting to do a regression discontinuity, QED, because you already have quite large amounts of data. So it's good practice to think about your statistical power, but it's unlikely that it is a hurdle to the deployment of your particular QED. Maybe the one regression discontinuity is the one where that sort of starts to be a bit trickier, because you need a lot of people right on that discontinuity, but still, I think it's good practice to think about it across the board. For instance, when you do survey research and you're trying to understand differences between groups based on surveys, and you're wanting to understand how many people you might need in your survey, to be able to understand these differences that you hypothesize would be there, you would still do a power calculation. It'd be a certain slightly different form of power calculation, but power nonetheless. If you're interested, look at all the polling stuff that's happening now. They do that too.
Absolutely. And then I'm going to squeeze in one final question, if that's okay, just because it's such an interesting question on power. So an anonymous writer is asking, is it valid to do a power calculation based on a fixed sample size? So if we already know our sample size, and then use the effect size produced as part of that calculation to analyze whether or not it's a kind of plausible sample. So the question is being pitched as, is it possible to almost reverse the logic of a power calculation? And of course it is the short answer.
Yeah, absolutely.
Yeah.
So it depends, right? So the question, as in, yes, you can do it. Of course you can do it. If what you're saying is, I have a sample who's willing to take part in an RCT, but I don't know what intervention yet I'm going to evaluate, which would be an odd thing to do, but let's say, and I know that this is my sample. I know I can never get more than that. What's the minimum detectable size I could ever get with this? If that's, I don't know, 0.2, 20% of a standard deviation, then your best bet is to go and choose an intervention to evaluate that is likely to have an impact that is larger than that, because then you're in a powered situation. And so that would be the logic of that. It sort of goes counterintuitively to how you would normally choose an intervention to evaluate, but I suppose you could practically do it.
I think also like choose your outcome very carefully, because that will also affect your effect sizes. And so yeah, if you know you can only have this amount in terms of your sample size, you then need to choose your outcomes very, very carefully to make sure it's reflected within your effect sizes and what you're likely to detect. Lovely.
Thank you both so much. We are at time, so that just leaves it to me to firstly say thank you so much to Lauren and Sonia for presenting today and for a really useful and informative webinar. Also to thank everybody who joined us and attended the webinar today. A couple of things just to quickly signpost to you. So in the post-webinar follow-up comms, we do have a number of additional resources that we'll be sharing. So there are some kind of very brief animated videos that explain the kind of key concepts of RCTs and quasi-experimental designs. We also have some nice case studies that are kind of a written up example of RCTs that we've run with the higher education sector and with some partners we've worked with. And also some nice written guidance documents that talk through the steps of randomized controlled trials and quasi-experimental design. So that will all be in your follow-up comms. And then just to say that we have 2 more webinars that will be taking place as part of this series. And the next one is on the 9th of July, I believe, a Tuesday. And these are a little different. They're evaluation surgeries. So with anyone who's familiar with the kind of concept of a surgery, you can submit your questions or queries or challenges in advance, and we will kind of dissect them with you during the webinar. So it's a bit more tailored or bespoke, I guess, in that you can ask quite specific questions relevant to studies that you're planning or interventions that you're running, and we'll kind of do a pre-mortem and picking them apart during those sessions. So again, we'll put a link to that in the follow-up com. So do sign up and submit your questions, and hopefully we'll see many of you there. But thank you so much for joining, and apologies, we are a little bit over. That's my timekeeping excitement for the questions on power calculations. Good to see you all. Thanks a lot. Take care.